Hello everyone, welcome to the session. Here I am going to discuss about the how we can analyze the measured IV characteristics of solar cell. Solar cell is a photovoltaic device is used to convert the light energy into electricity. From this, when we take in the current and voltage characteristics, voltage on x-axis and the current on y-axis, the characteristic curve is like this. The curve is like this. Here our question is how we can analyze the IV characteristic, obtained IV characteristic curve related to the solar cell. Here try to understand the curve. Here this is the x-axis point. Generally, as we know that x-axis point is nothing but y parameter 0 is 0. Here this point is represent the current value is 0 and voltage is the maximum. That is possible. That is called as open circuit voltage. That is called as open circuit voltage. I will discuss what is the meaning of open circuit and what is the meaning of other parameter. So this point is represented as open circuit voltage. Similarly, this is the y-axis point. This is the y-axis point, and here the y-axis point is nothing but x-axis parameter 0, that is the voltage value related to this is 0. So this is generally called as ISC, that is short circuit current. So from this graph, then first two parameters we can note down. One is the open circuit voltage, that is represent with the VOC. Second one, short circuit current, that is I take it as the ISC. These two parameters first I will note down from the obtained IV characteristic curve. So here we have a doubt. What is the meaning of open circuit voltage and what is the meaning of short circuit current? If you want to if you want to understand that kind of terms, then obviously we should understand the circuit diagram related to the solar cell. So first I will take the circuit diagram. This the, for example, this is the solar cell. To measure the IV characteristics, the voltmeter is connected parallel and ammeter in the series. To measure the different set of voltage and current values, we are taking the variable resistor values. So by varying the variable resistor values, there is a possibility to change both the current and the voltage. That parameters are used to measure the VI characteristics. This light, there is a light, this solar cell illuminated by the light, that is light fall on the solar cell. Here we take it as the white light. Now once the light is fallen on the solar cell, the solar panel absorb the light, and this because of the mechanism is what involved in the solar cell panel that creates the charge carriers. Based on the charge carrier conversion, there is a possibility to change the voltage and the current values. So the complete diagrammatic representation and the mechanism is given in the other videos. So here based on the, for example, here without giving the open circuit, without giving the variable resistor, these two connections are open. There is no possibility to move the charge carrier from one side to the another side. Then the voltage is maximum and the current is 0. That is take it as the open circuit voltage. Circuit is open. But what happened if it is connected with the metallic wire without giving any resistor? Just I given the metallic wire. Metallic wire means there is no restriction in passing the charge carriers. All the charge carriers can easily move. That particular situation is called as short circuit situation. In that particular moment, the current is maximum and voltage is zero because there is no restriction in the passage of current. And now again I'll take the voltage and the current. As discussed, this is the open circuit and this is the short circuit. In between, by varying the values of the variable resistor values, we can get different combination values, and the final curve is like this. The final IV characteristics curve is like this. By using this, I take it as the open circuit, and this point is taken as the short circuit. In addition, there is a possibility to measure the power values. There is a possibility to power values V into I. For example, here we'll get the x-axis point 0 and y-axis point SC, ISC. Here it is x-axis point VOC and y-axis point 0. Is it right? So similarly, here I take it as the x-axis point is V1, I1, V2, I2, V3, I3, V4, I4. So the power values P equivalents to V into I. So there is a possibility to measure the power values. So once we draw for different set of values, one particular set of voltage and current values, the product gives the maxima. That particular value is taken as the power maxima point. For example, when we draw the power versus voltage, so the power is increases like this, and it reaches to the maximum and then drop to the like this. This curve is related to the power related curve. This is related to the power. The point where the power is maximum, that is called as maxima power point, P maxima, power maxima point. The corresponding voltage and current is taken as the power maxima points. So from in addition to the ISC, that is short circuit current, VOC, open circuit voltage, there is a possibility to measure the P max. So that is nothing but Vm into Im, voltage maxima point and the current maxima. The product between, that means voltage corresponding to the P max is nothing but Vm. The current corresponding to the P maxima is represented like Im. So in addition to these three, there is a possibility to measure the fill factor, FF. It is in general represented as FF. This FF is a ratio between the Vm into Im, that is the maximum power, by ISC into VOC, that is the maximum power by short circuit current into the open circuit voltage. This is represent the fill factor, and the most important is efficiency. It is generally represented in terms of percentage. How much it can able to measure, how much it can able to convert the incident light into the useful charge carriers. So it is generally represented with the letter like neta. So here it is the P max by E, energy, that is sunlight energy, illuminated light, or the flux of the sunlight into the area. If it is in the percentage point of view, we'll multiply with the 100. So generally efficiency is nothing but, in case of solar cell mechanism point of view, the sunlight is absorbed by the solar cell and the sunlight is converted into the charge carriers. So efficiency is nothing but how much light intensity absorbed by the solar cell, how much it is utilized to convert into the charge carriers. So that parameter is represented as efficiency. Here the area, because energy illuminated is represented in terms of area, that's what. So P max by energy illuminated, that is sun energy into area, it is in the percentage, right? That's what it is multiplied with the 100. Generally the solar cell efficiency is like 10 to 15%. So the performance of the solar cell is decided by their efficiency values. So here, by using the IV characteristic curve, there is a possibility to measure the ISC, VOC, Pmax, fill factor and the efficiency values. If you want to measure the efficiency value, we need, that is, the light illuminated on the solar cell. These are the parameters which we can able to measure by using the solar cell IV characteristic curve. Right? Thank you.